Okay, annyeong class! So today we're going to do a Unit 5 check-in on 3 different types of questions that a lot of you guys got incorrect on the test last or 2 days ago. So we're going to go over it so that we can understand it and we fully digest it, okay? So let me do a problem, have you do one on your own, do another problem, have you do one on your own, and so forth, and I will collect this tomorrow, okay? Here are my 2 equations that I want to graph, and then I want to find out where they intersect. That's the solution. So first thing I'm going to do is label my y-intercept. My y-intercept here is 6. It's the guy that's not attached to x. It's the one that is constant, okay? And my slope here, since I don't have anything in front of, I do have something in front, but you can't see it, it's automatically a 1. Okay, so my slope is -1/1, because that's the same thing as negative x. Okay, so it's always the coefficient in front of the variable x. If there's nothing in front of the variable x, it's automatically 1. So now I'm going to plot 6 on the graph. So I'm going to go ahead and plot 6 on the graph like so. And since it's -1, I'm going to go down 1 over 1. There it is, because I went down 1 and over 1. I'm going to go down 1 and over 1 and plot there. Let me just do a different color. So I have this dot, I have this dot, I have this dot. You see the trend? Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, right? So I keep doing that, going down 1 over 1, and then I'm going to connect my dots. Okay? Alright, now I'm going to look at the other one. I misread it. It should be a positive 3x over plus 2. So then I'm going to get my other one, and y-intercept here is 2. It's this guy right here. And my slope is 3 over 1. I'm going to put 3 over 1 here. There's a 1 there, right? Because 3 over 1 is the same thing as 3. So here we go. I'm going to plot the first point, different color. I'm going to put a plot on 2 because that's where it started. It's my y-intercept right there, right? I'm going to go up 3 over 1. So let's go up 3, 1, 2, 3 over 1. Put a point there, go up 3 over 1, put a point there, and draw my line. And if you can see, it intersects right there at, oh, I moved it, but it's at 5, 1, okay? So my intersects at 5, 1. There we go. So this guy right here is the point, or 1, 5, I'm sorry, 1, 5, because I have to go x first and then up 5. So my answer is 1, 5. All right, let me have you do one. Alright, I want you to do this one and put number 1 on there. Y equals -4x plus 2 and y equals x minus 3. Remember, it's the same thing as 1 over 1, same thing as -4 over 1. Identify your slope, identify your y-intercept, and graph from there. Okay, the second type of problem I want to do is I give you a graph and you give me the equation of the line. Okay, so this is easy. First thing you want to do is find the y-intercept. So here's the y-intercept right there. And what's the y-intercept? It's going down 1, 2, and -3. So my y-intercept is -3. Then I want to find the slope. Remember, there's 2 pieces. There's 2 ingredients, slope and y-intercept of an equation. I want to find the slope. So if you look at these dots, or I could find anything. I could find dots that are here. Here I go down 2 over 1, right? Down 2 over 1, down 2 over 1. I keep going down 2 over 1. So down 2 over 1. My rides overrun. So -2 over 1. So then, it's a -2 because you can see it's going down, right? So now I can write it in slope-intercept form. My slope is -2 over 1, x. My y-intercept is -3. Remember, my slope always goes with the variable x, and my y-intercept is always a constant. So I'm done here. I could rewrite this as y equals -2x minus 3. Okay, I want you to do this one. The scaling is by 1, so this y-intercept is at 2. Okay, and then do the rise over run. It's a negative slope again. So figure out what the slope is, the y-intercept is, and put it in y-intercept form. Okay, that's number 2. I will check this tomorrow. The last type of problem I want to go over is verifying algebraically that -1 and -5 is the solution. Right? And I'm going to do this with the table because the table helps me keep organized. That's how I like to do it because I'm very disorganized, so I have to have a table. So this is my x point, this is my y point. I want to show that this is true for these 2 equations. That when I if I graph it, it hits it. It intersects at -1, -5. But I could show this without graphing it. I could do it algebraically. So my x, my input is -1. I have to show for both equations. I'm going to do this one first. 3, I have the input of -1 minus 2. Okay? So then I do 3 times -1, which is -3. So this up here is -3 minus 2, which equals -5, -5. And that's true, right? Because my y is -5. True. I also want to check with this one. So I want to input -1. So I have a negative. Here's my negative for that, negative. And then I have to put in the x as -1 minus 6. A negative times a negative is a +1, minus 6 is a -5. Check. So I can say that it is true. Okay, it is a solution. If it doesn't equal -5, then it is not true. Okay, so your last problem, number 3, is to verify that 2, 5 is a solution to those two equations, y equals 3x minus 1 and y equals -2x plus 9. Do the table and algebraically show me that 2, 5 is where those two equations cross. Alright? I hope you have a good day. I will check this tomorrow and make sure you understand it before continue to move on to chapter 6 or unit 6. Okay, I hope you have a great super day. 안녕. 사랑해.